Friends, and in this video I'm going to describe you the concept of the Numpy arrays and the Matplotlib, how to plot the data on the Matplotlib.pyplot. So here I import one numpy, so import numpy as np, and then I import matplotlib.pyplot as plt dot pyplot as plt. So I have created one array, and its name is AR. So AR equal to np dot array, and it has 7 elements into it. Now I create another array called br equal to np dot array, and then I will pass certain elements, 7. It should also, or it have 7 elements into it. Okay, some red lines are coming, don't worry. I just take any 7 random values, like just to make it a one-to-one mapping. So it's np dot array. So now I will have to plot it, so I'll call plt dot plot, and I'll pass these two values, ar and br. Ar one array 7 values, another array also has 7 values, and then the plt dot show. So now it will print. Just let's see and see how it works. So my friends, here it goes, and you get a one separate window with a graph on it. One represents x-axis, the other part represents y-axis. This is how a 2D graph generally are. And on the first one is x-axis, like the 1 2 3 4 5 6 7. You can say that the first set of values is 1 2 3 4 5 6 7, and second set of values is 3 4 something. So now, so AR goes along x-axis and the BR goes along y-axis, 3 7 5 6. Now I want to make it a better look, so that I want to provide some labelings on x-axis. So plt.x label as x-axis, and plt.y label as y-axis. So now you see, you will find x-axis labeled and y-axis labeled. So now see, x-axis, on the x-axis you see there's a x-axis written, and on y-axis you see y-axis is written. So this is called labeled. Now I want to give the title to the graph, so I will call the function plt dot title, and this is my first plot. Okay, so it will have a title called my first plot. So just see, here it comes, my first plot. This you see on the top. So the Windows name is figure 1. Now this is how, if you see this inbuilt function, when you remove the cursor, it just says the coordinate. Now question is that many times we have to, now suppose if I change the values of the BR as some other values, like the graph looks like zigzag because the numbers were different. Now if I change the graph, then the graph definitely will change, because if the data will change, then the graph will change accordingly. So I make it 10 30 40 50 60 70. It looks like a uniform data. Now just see how this works. So now let the pop-up window come, and then you will see, oh, so this is a straight line graph. Now just should look at the values on the y-axis. It is starting from 10 to 70. Question is that sometimes we need to just have different kind of values to work with them, and every time now you cannot have this kind of graph. So suppose if I create one array with the linspace, so np dot linspace, and the size I give it 1 to 5, and the 200 values we are expecting here. So now I create a function, because this is, I'll passing AR values to a function, and the function according to rule will return me a set of values, and that I'll store it in the BR. So like suppose when you are plotting x on the x-axis and the sin x on y-axis, so you should pass x and it will give you the value. So this is t into t. So I'll pass the whole AR function, and then this AR function, each and every element will be squared and the return, and this will be stored into the array BR. So just I call the function and name is fun, so fun, and I pass the whole array created by np dot linspace, and it returns me a value which is stored in BR. So now again I'm plotting AR on x-axis, BR on y-axis. So this is a square function, you can say t square kind of. So this is the graph of t. Now you see the value between 1 to 5, and there are so many values between them. So that is not a problem. This is our square function, and on y-axis you have BR. So this is squared value. If I change these values t as because the previous case it was a graph between the x and x square. Now it is np dot sin t. So np means the sine functions in the numpy arrays. So now here you see it will be plotting np dot sin t. So here it goes. This is a sinusoidal waveform. This is starting from this. Now if I make it, because you know sine values flip between -1 to 1, so I just try to give a range of values between -1 to 1. Let's see how it works, so that you can have certain negative values also between. So the graph will shift, and then now it looks little flattened because the units are not proper. So this is how it goes. This is -1 to 1. On the x-axis you see it between -1 to 1, and the y is at the center. So now if I make it more points, then what will happen? Like suppose, so now I make linspace between -1 to 1, and then again you're getting the graph like this. By squeezing and flattening, its shape is remaining same. So now I have another functions, some other functions also we can call. So now this is your sine function. It is looking like a sinusoidal wave, but since it is squeezed between two values, that's why it is looking little different. So between 0 and 1. So this was between -10 to 100. Yeah, now I make it between -10 to 10, and then again I'll call the sinusoidal function. Now let's see how the spanning comes. Yeah, little better. Now this is nicer plot. So this is between -10. This is the normal sine function. You see, if you just look at the middle, you can say that if you just plot one graph, this is your normal sinusoidal functions. This is called a sine graph, trigonometrical sine. Now if I make it a cosine function, then what will happen? So just make it np dot cos t, and then you will get your cosine function. So now friends, and then if I want to make it a tangent function, then what will happen? Then I have to pass np dot this is our tangent function. It looks, these are the points where this is undefined. This graph is not taking it into consideration because this scaling is little different here. Now if I want to make it np dot some other functions like np dot sqrt function, and then I pass t, and since I have taken the range of values from -5 to 5, and we know that the squared function is not defined for negative numbers, so this will show something, but it may also send some error message. So the graph is showing, but it shows one error. It says that invalid value encountered in the sqrt function, and that is the negative number, because square root of negative number is not a real number. So if I make it between 0 to 5, it will be more better. So now between 0 and 5 no such errors would come and the graph will be same. So this is the square root function. You can say sqrt function, square root of x, the square root of t, whatever you call. Now if I make it again between -5 to 5, then let's see how it goes. It will have a V shape. So now if we just find another function, and you know that the signum function is a function defined as the mod x upon x, so it is already absolute t, and divide by t, it will give you the signum function, which is looks like a Z shape. So this is signum function. Now if you want to change it to some other type of function, then exponential functions like the np.expt, so it is just like e to the power t function. So here it goes, and now you see the e to the power t function. This is how it behaves. Now you can also find e to the power minus t just by changing the t to minus t, and then yes, it's e to the power minus t. So this is how it goes. Subscribe to our channel. Keep on learning with us. Thank you very much.